So in this video, I'll be showing you the capacity test of this LIshen 202 amp hour cells that I have been using for the past 3 years. Okay, so I built this battery pack by myself in 2021. So I got the cell in 2021 from a store on Alibaba, Zuba. Okay, so these cells are 202 amp hours LIshen cells. So I got them as grade A brand new cells. Okay, so I built the batteries with this Dali BMS because it was the most popular in during that period. So it was the Dali BMS many DIY users are buying for their DIY packs. Okay, so I use this HDF box, and I use this padding foam on the side as my fixture. So I didn't go with the traditional method of using spring to lock the cells into place. So I went with this type of fixtures, just holding the cells in place and not allowing the cells to move around. I'm dismantling the cells and I'll be discharging the batteries down to whatever the inverter can allow me to discharge to, and I'll be charging it back up to see how much capacity do I have left in this battery after 3 years of usage. If you notice, you will see that okay, there's a small bulging on the cell. That's why I got this. So I got this to see what's the new length of these cells. So let me check 1 or 2 cells and see how swollen the cells have become. So here you can see this is on the millimeter position. So it's at the millimeter position. So you can see at the top here we have 55 mm. So if you take this down, you can see as we take it down, you can see, so there's not much bulging happening on the cell at all. So you can see it's ranging from 55 point something, that's about 2 millimeter swell. You can see 55.5 at the top. So if you take it down, you can see the highest we have here is 56. So if you say the cell are swollen, yes, that is correct, but only by 2 millimeters. Okay, so this is like 2 millimeter swollen level. Okay, so I take another random cell. So at one point I was charging these batteries with 80 amps because of the power condition, so I need the battery to be charged as fast as possible. But as time goes on, when I have a stable power and enough solar panels to charge, then I regulate my charging to about 40 amps, which is 0.2 C. I've been charging this battery for the past 1 year plus with 3.5 volts per cell, that is 28 volt float and bulk. So when people tell me about lithium battery and they say, okay, that charging profile is too high, you don't need to keep cells higher than 3.45, I always go against that because I believe when the battery stops charging, the temperature starts reducing, and when the temperature starts reducing, then your cells are fine, because if the temperature is not increasing after it attains 3.5, then there's no harm to the battery, so there's no damage on your battery. So you cannot damage your battery by keeping them at 3.5 volts for a long period of time. If you keep the temperature above 40 degrees, that's when you can say you are physically damaging the battery. So I've been watching my cells over time for the past 3 years, and once it's full, so once it's 100% full and is on 28 volts, the temperature drops to 31 degrees. So at 31 degrees, 3.5 volts, I don't think I will have any issues doing that on the long run. One of the things I noticed about these cells is that the bus bars that came with it covers the entire terminal, okay, giving it a well grip connection. So when you connect this on the batteries, you have a better connection compared to the new cells that are coming right now. So when you buy a new cells, they have this little connection on the top which affect the internal resistance and all that. So when I build my pack, then I will always share my deviation to be very close to 0 deviation. (100 amp hours into this battery. On the negative terminal, we can see this is the temperature, is about 33 degrees. Okay, so 33 degrees
over an hour of charge at the terminal. Then the positive side is showing only 30, 31, 30, let's say 32 degrees. Okay, so this is 31.5, and inside the cells we have 31 degree as the average. 187 amps into this battery, the current is dropping. Okay, so after 2 hours we have 41 degrees on the terminal. On the positive side we have 40 degrees as well. In between the cells we have about. Okay, so we are done. So the test is completed now, and we have 192 amps charged into this battery. Okay, so I can see the internal resistance is increasing and the current is reducing. Okay, so as the internal resistance goes up, the current drops. Okay, so we can see here we cooked the battery a bit to about 40 degrees at some point, but now that the charging is reduced, then we can see the temperature is reducing. Okay, so normally I don't do 100 amp charge into these batteries. Okay, so I've been using 40 amps to charge this battery, and my target voltage is 28 volts, as you can see on the meter. So I don't charge beyond 28 volts, which has always been my recommendation for charging. Okay, so I do 0.2C most of the time, that is 40 amps charging, and 28 volts or 3.5 volts per cell.
95% capacity back into the battery at a charge rate of 0.5C, which is about 100 amps going into the battery. And you can see the temperature increase after about an hour 20 minutes into the test. So the temperature of the cells increase. So charging the cells from 0 to 50% does not really affect the temperature in the batteries.